Alright, here we are doing page number 1 of linear relations. It asks us to find the slope of the line shown in the graph. So the first thing I want to do is remember that slope, we refer to as m, it's equal to rise over run. Rise is up and down, run is left and right. It's better just to think of it to the right, it just makes it easier. So what I want to do is find a point on the line. There's one point, it's a nice point. Find another nice point. So when I mean nice point, I mean it crosses right at whole numbers. Now I could pick this point up here, or I could pick this point down here. It's better to pick the two closest ones because then we don't need to reduce any fractions. So there we are, our 2 points on the line. So I want to get from one point to the other point, but only by going vertically and then horizontally. So here I'm going to go up 2, so that's plus 2, and then over to the right 1, plus 1. So what that means is my rise going up is 2, and the run is positive 1. Now you could leave it like that, but that wouldn't be in lowest terms. It just is m is equal to 2. There is another way. The other way is using 2 points. The equation goes like this. Slope equals y2 minus y1 all over x2 minus x1. So this is another way to do it if you just are given 2 points. Now for this one, if you wanted to use it, you have to label the points. So this point right here, x is 0, then y is negative 3. So you have to remind yourself this is y, this is x, this isn't labeled on this graph, but that's okay. On this point right here, the x is 1 and the y is negative 1. So what we do is we take those 2 points, point 1 and point 2, and put them in our formula. So when we do that, this is one point right here and this is the other point. These are the x's on the bottom and the y's. So it's like you have to separate them. So I'll take this point first. It's 0, negative 3. So I put in the 0, put in the negative 3. Then put in the negatives or minuses from the formula, and then brackets for my second point. Here's my second point, 1, negative 1. X is 1, y is negative 1. Now we have to do some math. So if you want to use your calculator, you can get your calculator out, or you can see that I have a negative and a negative. Subtracting a negative makes actually like a positive. So here we have negative 3 plus 1. Negative 3 plus 1 is what the numerator becomes, and this is 0 minus 1. Well, 0 minus 1, if you have nothing and you subtract 1, you're left with negative 1 or minus 1. So I'll come up here. The numerator, if you want, you can do this on your calculator. You put in negative 3 plus 1, it's going to get you to negative 2. And then the denominator is negative 1. And at first I was thinking, wait, that doesn't look right, because look up here I got a positive 2. But look here, we have 2 negatives. So if you did that in your calculator, or you can also remember a negative divided by negative ends up being a positive. So 2 divided by 1 ends up being 2, and we get the exact same answer. You don't have to do it both ways. You just choose whichever way you like better. But that's 2 methods for one slope. So I'm actually going to go over to this one since we just did slope, and this one asks me, on these 4 axes, show an example of positive, negative, 0, and undefined slope. Since I just did a positive slope, why don't I put that in there? So a positive slope has to be going upwards. So as x increases, y increases. So that means as x is going to the right, y is going up, because x is getting bigger to the right, y is getting bigger when we go up, and that ends up with a diagonal line upwards. Okay, so but with a negative slope, only one of them is decreasing. So as x goes to the right, y is actually getting smaller or lower, and we're left with a downward. So this is positive, and this is negative. And the steepness just has to do with the size. So as long as it's going up, not that way, but this way, anything like that, until you almost get vertical, that would all be positive. Here, negative, going downwards, not as big a negative slope or a really big negative slope like that. So now let's do zero slope. Zero slope means no slope. And a no slope is a flat line, even though that looks a little bit upwards. That's a flat line. Flat. Okay, no slope. The last one, undefined. Undefined is the opposite of flat. It's vertical. Goes straight up and down. Vertical is an undefined slope. This one's flat, it's horizontal. Okay, that's no slope. Another way we can remember that is y is equal to some number. That's what the equation would look like for a line. This could be y is equal to -2. For a vertical line, it looks like x is equal to some number. And there's a vertical line, so that could be like x is equal to +2. Positive increasing, negative decreasing, zero or no slope is flat, and vertical is straight up and down. So let's go on to pause there for a second. If you want to pause it to get all that stuff down or check over your work, you can do that now. I'm going to go to the next two horizontally. So for this one, equation of a line, what I need to remember is y is equal to mx plus b. Well, from above, we realize that m is slope, and hopefully remember that b is the y-intercept. The y-intercept is where a line crosses the axis. In this case, we're talking about the y-intercept, so we're talking about the y-axis. So if I look here what they've given me m and they've given me b. m is equal to 2, b is equal to 3. It's as straightforward as subbing in for the m and the b. Those are just substitutions. The x and the y are there as the variables that change for a line. So I write down the y, the m is 2, write down the x, and the plus 3 for b. So when you substitute, it means that you don't write the letters anymore. So instead of writing b, I write 3. Instead of writing m, I write 2. Now, it's not good to write it with brackets. We should simplify it. There's nothing that I need to do with signs here because I don't have negatives and whatnot. So really, I could write that as y is equal to 2x plus 3. That would be a better final answer. Okay. Now, if we go on to the next one, m is equal to -1, b is equal to 0. So if I write that in, I'm just straightforward substituting. Instead of writing m, I'm writing -1. So there's -1, I write the x, then I write plus 0. Well, when I add 0, why bother writing that? You really shouldn't. Let's simplify this. That was y is equal to -x. You can write it like this way, or you can write -1x, but when you see an x, that always means that there is one of them there. So that would be the most simplified. But I would accept a 1 in front of there if you wanted to write it. But it means the same thing if you just write x. And now down onto this one. This is the same graph as the first one I did, so we actually already know what m is equal to. m is equal to 2. So really, I just need to find the y-intercept. So let's remind ourselves, this axis is the y, this axis is the x. So if I want to find the y-intercept, I look and see where the line crosses the y-axis. And that's right there. That's at 0, -3. So what that means is b, that's the y-intercept, is equal to -3. So what I do is I sub it in. Y is equal to mx plus b. My m is equal to 2. Write down the x. Write down the b. The b is -3 in this case. But I want to simplify this. So 2 times x is just 2x. And then I want to worry about this. I don't really need brackets here, but I have a positive and a negative. That's going to end up being negative 3. Because when they're different, it ends up being negative. So y is equal to 2x minus 3, because b is equal to negative 3. So since we're looking on graphs, I'm going to go ahead and do number 4 at this point. So y is equal to negative 3x plus 2. This is still referring to y is equal to mx plus b. So b is always a good starting point because that gives you an exact point to start at. So that is y is equal to 2 because that's b, this is b, this is m. M is equal to negative 3, b is equal to 2. So if I go on the y-axis, the y-intercept is positive 2. Right there. Now let's go ahead and look at slope a little bit closer. M is equal to negative 3. But slope should have a rise and a run. If I divide anything by 1, it never changes. So the denominator on every whole number is a 1. So I'm going to look at this and say, well, what does this mean? Well, the negative 3 means down, and the positive 1 means to the right. So I want to go down 3, 1 to the right. So I start at my y-intercept, down 3, 1, 2, 3, 1 to the right. And I don't draw the dot until I've done both the rise and the run. The rise happens to be down 3. 1, 2, 3. The run is 1. Put in the dot. 3 dots is probably enough, but I can see I have enough room for a fourth, so I'm going to do it. Down 3 to the right 1. Once I get a couple points, take your ruler, connect your dots, and there you are. You're a line. And let's do the next one. So over here, I can see that it's in the slope-intercept form. So here is the slope, here is b. Make sure you take the sign in front of b. You can't just take 3. You need to take the sign in front of it. So b is equal to negative 3. Slope is equal to 3 over 2. So that's going to be up 3 to the right 2. I start on my y-intercept. Find my y-intercept. It's negative 3. And I'm always on the y-axis for the y-intercept. So I'm going to go up 3, 1, 2, 3, and over 2, 1, 2. Draw my point. Again, I draw my point when I'm done doing my rise and my run. Up 3, 1, 2, 3, and over 2, 1, 2. Now, if you like doing run first, you go ahead. It's going to get you to the same point. To the right 2, up 3. To the right 2, up 3. It doesn't matter. Just pick a way that you are confident with and stick with it. Draw a straight line. Take your time to line them up. Put arrows on the end. All right, so now we're going to get into a little bit more math here. Now you're not having any graphs anymore. Here I'm given 2 points, and I think, now what am I going to do with that? Well, if you know 2 points, you know the slope, because y2 minus y1 all over x2 minus x1 is the slope. So I'm going to go ahead and sub these in. So this is x1, y1, this is x2, y2. I'm going to put some brackets in here. It makes it easier for me to sub in. Keeps me all nice and neat with my signs. These ones, these negatives, are from the equation. So here's my y2, my x2 and my y2. So x is 4, y is negative 5. So I start in the bottom, 4, negative 5. A point kind of goes vertically, which I know is odd, but that's the way it is because that's the formula. X is on the bottom, y is on the top. Take your second point, 2, negative 1. Now you just have to do the math, getting rid of your brackets. So negative 5, and I have a negative and a negative, or minus and a negative, that becomes positive. And you have 4 minus 2. Now you go ahead and put this in your calculator. You're going to get slope is equal to negative 5 plus 1 is going to be negative 4. The denominator becomes 4 minus 2, which is just 2, and this simplifies to negative 2, because I have a negative divided by a positive will give me a negative, and 4 divided by 2 is 2. So now I know that m is equal to negative 2. But to get the equation of a line, I also need b. So how do I do that? Finding b, what I do is I pick a point. I don't care which point, as long as it's a point in the line. So it's 2, negative 1, and I know m is equal to negative 2. So I use my equation, y is equal to mx plus b. And what I can do is substitute in for y, substitute in for m, and substitute in for x. Using these three parts, I'll be left with b, and that's what I'm going to solve for. So y is equal to negative 1, m is equal to negative 2. I should use brackets, and x is equal to 2. Put brackets around that, but it's by itself, so it's not terrible if you didn't put them. And b, I don't know what that is. That's okay. That's what you're looking for. So you want it to be in the equation. So let's go ahead and simplify this. There's nothing to do there except for not write the brackets. Negative times a positive ends up being a negative. 2 times 2 is 4, left with plus b. So now, these are terms. 1, 2, 3 terms. But what is, I want to isolate b, I need to get it by itself. So I want to get rid of negative 4. What's the opposite of negative? It's positive. So I put positive 4, I want to add 4. But whatever I do on one side, I must do on the other side to keep everything balanced. Because this equal sign is like a balance. So this right here, I chose that to become 0. Over here you have to do the math. So it's like negative 1 plus 4. That is going to be plus 3. And that equals b. And that's what I wanted to find. I wanted to find b. So there's my two parts, my m and my b. I've run out of room here, but I can write it here. Y is equal to m, which is negative 2, write down the x, plus b. So I wrote plus b. b is actually equal to 3. Don't forget what you're doing there. There's my 3. Now it's a plus, so we can just write 3. Let's simplify it. Negative 2 times x is just going to be negative 2x and plus 3. And there is my equation. The last one to do on this page is using intercepts. Intercepts is plural. So I want to use my x-intercept, which is where y is equal to 0, and my y-intercepts, where x is equal to 0. So I'm going to use that to find 2 points. As long as I can find 2 points, I can connect them to become a line. So let's do our x-intercept first. Our x-intercept is when y is equal to 0. So I'm going to write down the formula, and I'm going to substitute y is equal to 0. Well, what happens then? That means y is 0. I write 0 instead of y, and 0 times 3 just ends up being 0. And I'm left with 2x equals 6. I just write down the terms that are left over. But I want to solve for x, because I need a point. I know what y is. I've set it equal to 0. So the 2 and the x are multiplying. The opposite of multiplying is dividing. So 2 divided by 2 is 1. I'm left with x. And 6 divided by 2 is 3. So now I know my 1 point is x is equal to 3, y is equal to 0. So let's go ahead and find that. Y is equal to 0, x is equal to 3. It's right there. Let's do that again, but I'm going to do it for the y-intercept. And that's when x is equal to 0. So I'll do the same thing, write the equation. Seems repetitive, but it's different. Now the x is equal to 0, and we leave everything else. But 2 times 0 is 0. That term just ends up being 0. I'm left with 3y is equal to 6. I want to get rid of the 3. So some people think I need to minus 3y. I don't want to minus 3y. I don't want to get rid of the y. I just want to get rid of what's in front of the y and they're multiplying. So the opposite of multiplying is divide, and I have to do that on both sides. 3 divided by 3 is 1. 6 divided by 3 is 2. So I'm left with y is equal to 2, because 6 divided by 3 is 2. So I put these two things together. Oops. I thought that was a negative 2 for a second. It's not. It's just a positive 2. So I'm going to go where x is 0 and y is 2. And then I take my ruler or any straight edged and I connect those 2 points and draw a line. I can actually see it has a negative slope. And let's say for some reason I wanted to check something like that. Why don't I, for fun, see if I can put that equation into the slope-intercept form. It'd just be one way of checking that I did it right. So if I take 2x plus 3y equals 6, I want to make it look like y equals mx plus b. So that means I want to keep the y here, but I want to get rid of this whole term, 2x. So this is the difference between getting rid of a coefficient and getting rid of a whole term. This is a whole term. There's actually 1, 2, 3 terms in this equation. So whatever I do on one side, I must do on the other. The reason I chose that was to make it 0. So here I'm left with 3y. This is equal to minus 2x, and I have a 6 plus 6. I stuck it in there because I'm trying to think